So this week, we've been doing a little playing around with deviations, and the goal is to reach standard deviations. So the goal is to go from basic deviations to standard deviations. The reason I'm making this video is because I know it gets a little heavy, learning about deviations. And even though we've been taught what deviations are, a lot of us don't really natively understand them. Think about it like give and take. That's the goal. We want to find out that from an anchor point, from a middle point, X bar or mean of X, which is any variable. In our example, we have used ages. What is the difference? How much fluctuation do we see in our group of people that we're interested in? I mean, somebody who is 35 years old, if the mean is 37, they have a deviation of -2. But if somebody is 40 years old, then they have a deviation of +3. So how does this, if you think about it, that's where MAD comes in, MAD, which is a mean absolute deviation, because the mean is decided based on all the observations. So when you take the average deviations or movements from the mean, it all cancels out. So how do we find an average of the movement of an average person in the group? So for that, one option is to use the absolute values. And when we use the absolute values and get the MAD, there is one problem, which it works in terms of general understanding, but the problem is in terms of calculus. See how when we take the original deviation values on the horizontal axis and take the absolute value of the deviations on the y-axis, see how we get these sharp lines? And this does not allow us to use this for higher level calculus methods. So the other way that we can look at positive and negative values and convert them all into positive values is instead of taking an absolute value, we take squares. The thing with squares is that it gives bigger weights to people that are farther away from the mean. See that? Like if you look at this person here who's 30 years old versus 37, there's a -7 distance. And so this would be 49. And nobody caught this. This was a mistake. It says it correctly up here, but it doesn't say correctly down here. But anyway, we're going to pretend that I didn't make that mistake. But basically, it's a question of figuring out the distances and the area of those distances. That is the reason why variance, or sum of squares on which variance is based, is in years squared rather than in years, right? So we're changing the units. We are now looking at the area rather than just a line. And this is the variance. And if you see the variance, if you take negative and positive values of the deviation, it converts it into squares, but it's a smoother movement of the curve. This works very well with calculus, which is what normal distribution and a lot of other formulas are based on. So using sum of squared for finding the mean deviation is preferred to the MAD method, right? And then if we take the square root of these variances, after we find them, so when we find the means, that's how we get the variance. And then the square root of the variance gives us the small sigma or the standard deviation. And one of the easiest things to know is if you know the standard deviation of something like, in this case, our standard deviation is 5.13 after all the calculations, 67% of the people are going to fall between 5 years from the original mean of 37. So if you just want to round it off, it would be, between basically 32 to 42 years old. Well, I hope this helped understand the concept of deviations and standard deviations eventually a little bit better. Drop comments if you have questions, and I'm always happy to answer them. Thank you.